Hi class, let's take a look at problem 9 and 10. Now, for both of these problems, I'm going to use a slightly different approach than what we did on the previous problems. So for example, on problem 9, let me reference a similar problem where we actually work with the fractions. So as you can see here, we subtracted the 1/4 and we basically deal with the fractions throughout. And what I'm going to do on this problem is the following approach. So this is what typically happens to be the fastest way of completing this problem. And this is by looking at the lowest common denominator of all the fractions. So in this case, you're looking at the LCD, and notice that in the LCD, you're looking at 2, 4, 6, and 12. So in this situation, the lowest common denominator is 12. And then what we want to do here is cancel the fractions by multiplying by the LCD both sides of the equation. Now keep in mind that the 12 is going to multiply each one of the terms. And what happens here is if we found the LCD correctly, our fractions are going to cancel in the next step. So for example, let me actually rewrite the original problem and then the 12 so you can see the cancellation. So here we have 1/2 of a minus 1/4. This is equal to 1/6 of a plus 1/12. And then technically what happens on the background is that every one of these values gets multiplied by 12. And since 12 is the lowest common denominator, it's going to divide each of the actual fractions into an integer. So your fractions get canceled on the first step. So for example, for the first value, 12 divided by 2 is equal to 6, or 6a. 12 divided by 4 is equal to 3, so we would be left with minus 3. It's equal to 12 divided by 6 is equal to 2, so this will be 2a. And 12 divided by 12 is 1, so you would end up with plus 1. So notice that after the multiplication of the LCD, all your fractions cancel. It's what I have here in green, and you're now left with integer values. So at this point, we're just going to be subtracting the 2a. So we're left with 4a minus 3 is equal to 1. And then we can add the 3 to both sides. So 4a is equal to 4, and then dividing at this point by the 4. So we're looking at our final solution. The a is equal to 1. So this was just a slightly different approach. Typically, if you have multiple fractions, it's just easier to cancel the fractions on the first step. And as we compare to the previous problem, I didn't cancel the fractions on the previous problem, on problem 8. This is because, well, I saw that the fourths cancel in one subtraction. So that occurred here. So it was just easier to do it in that format. But we could have multiplied by 4 all the values except that would have made the 16 a larger value. Now let's take a look at problem 10. And problem 10, I'm also going to do it slightly different. Let's take a look at a previous problem that involved decimals. And this is going to be back in here, problem 6. Now, notice that problem 6, what we did here is we just basically work with the decimals. And the first step, actually on the second step, we subtracted the 6.45, so that took a little bit of algebra there. And then at the end, we ended up dividing using long division. So this approach, it's perfectly fine, but it may take a little bit longer. So here, instead of multiplying by the LCD, its equivalent form is going to be multiplying by a value, both sides of the equation, that's going to cancel the fractions. Not the fractions, sorry, the decimals. And what I'm trying to do here is make the smallest value in terms of the decimals an integer. And notice that your decimals contain 2 decimal places, so those values are actually smaller, since technically this is 0.80. And in order to make those values into an integer, we have to multiply by powers of 10 that are going to have 2 zeros. So in this case, by 100. And what this is going to do is every one of the values gets multiplied by 100, and then our decimals get canceled, and now we just have integer values. The only problem is that some of these are going to be large. So for example, 1.2 times 100, it's going to move the decimal 2 places to the right. So this is going to be 120x minus 91. This is equal to 80x plus 229. So in this approach, in the first step, we cancel the decimals, but that actually makes a little bit of a mess because we do end up with larger values. And what we're going to do here is put the x's on one side. So let me subtract the 80x and the 80x. So this is going to now be 40x minus 91 is equal to 229. And let me add the 91 and the 91. So we're left with 40x is equal to, this is going to be a 0, and 9, it's going to be a 0, you carry 1, so that's going to be a 3, so 320. Let me actually do that sum on the side. So this is 229 plus 91. That's going to be a 0. You carry 1, 10, 12, and we carry 1. So that's going to be a 320. Okay, we're good. And then at this point, I'm going to be dividing by the 40. So we're looking at, well, the values of x is equal to 320 divided by 40. You can cancel one of the zeros. And then we're left with technically 32 divided by 4, or the values of 8. At this point, x is equal to 8. For a moment there, I thought that we had to do long division. Okay, that's actually it for these two problems. The next set of problems we'll deal with applications. And I just wanted to do a set of problems where after we do a little bit of problems and get experience, you can finish them faster. And that would be by multiplying by the LCD, all your fractions, and then also multiplying by powers of 10. And in that case, cancel all the decimals and end up with integers. Here, we could have actually ended up with decimals too. So in that case, you would have done the long division and carry at least 2 decimals. That's actually it for these two problems.